Right now, it seems like everyone is obsessed with learning about AI, but most people are missing the one skill that actually makes you dangerous with it: prompt engineering. It's a buzzword that people throw around a lot, but if you want to make any kind of money with AI, it's something you've got to know, because there's a huge difference between a good prompt and a bad one. And if you master this skill, you can design and sell AI systems for thousands of dollars, just like I've been doing for the past 2.5 years. I'm packing everything I know into this one masterclass. So let's get right into it. So most people prompt like they're asking a question, but a good prompt is actually a little bit more like a job description. It tells the AI who it is, what to do, how to do it, and in what format you want it in. Every prompt you write is either making the model smarter or it's setting it up to fail. So Google has a simple 5-step framework they teach, which is task, context, references, evaluation, and iteration. Think of it like you're giving instructions to an intern. You wouldn't just say, make content. You would say, here's the project, here's some background, here's a few good examples, and here's how I'm going to grade you. Now get started. When you're prompting one of these large language models, every message you send falls into one of 3 types: system, user, or assistant. They're all different, but knowing how to use them unlocks a ton of control, especially if you're using the API. System messages are kind of like a set of instructions. This is where you define the rules of the conversation, the role, the tone, the format, the structure. You're basically giving the AI a job description before it starts working. In ChatGPT, you don't normally see this, but it does have a hidden system prompt, which is running in the background. So when you type something, you're always sending what's called a user message. Because you can't edit the system prompt directly, you're forced to jam everything: the role, the format, the examples, all into the user message. And it still works, but it's just not as clean or reliable. When you use the API though, you can set the system message yourself, and that's where things really get powerful. Now you can define everything up front once, and then send in user messages that are short, dynamic, and focused only on the new task. User messages are where you feed in your actual inputs, like the task, write a tweet about X, or the data, here's what I scraped from this site, or even the goal, format this into a sales pitch. And finally, assistant messages are just the AI's responses. What's interesting is when you use the API, you can fake these. You can preload the conversation history and gaslight the model into thinking it already said something. It reads those assistant messages just like they were its own words. And we've used this to guide tone, create memories, or even add in little persuasion tactics. Before we dive into the actual prompting tips, there's another thing you gotta understand. AI models don't read or think in words like we do. They break everything down into tokens, which are chunks of text that might be a word, a part of a word, or maybe even a punctuation mark. So even if your prompt looks short, let's say 28 words, it might actually be 34 tokens. And that matters because every AI model has a token limit for how much it can read and write in a single go. And more importantly, pricing is based on token count, not word count. So trimming your prompt down without losing clarity can actually save you a ton of money, and it'll make your prompts faster. That's called prompt optimization. And you can use tools like OpenAI's tokenizer to check your token count, or platforms like PromptLayer to dig deeper and compare your prompt performance. And this is where most people stop learning prompt engineering. They learn to say, act as an expert, and think that's the whole game. But the role you assign the model does matter a lot. Just look at the difference between these 2 prompts. You see how the second one shifts tone, structure, and clarity of the actual output? It instantly changes the way the model thinks and writes. And you can be as specific as you need for whatever you're trying to accomplish. Like, you might see better results if you're telling the AI it's a children's book author instead of just a regular author. So whenever you prompt, ask yourself, who is this model supposed to be and how much detail is needed? Then tell it and provide as many details as needed. Speaking of better results, you can provide context to these models as well. The more context, the better the results. So instead of prompting a model like this, you can prompt it like this. You're actually adding in extra information for the AI to fully understand what it's supposed to do. You'll get way better results because the model can fully understand the exact thing it needs to accomplish and has background information in order to do its job best. And if you want more control over what the AI gives you, just add formatting to your prompt. You can ask any of these AI models to respond in whatever structure you want. Text, bullet points, tables, even code if you want. But the most useful format we've found for automation so far has been JSON. It's just a clean, structured way to organize your data that looks like this. And we use it all the time at Friday Labs. Because when the output is in JSON, tools like Make.com or N8N can automatically parse it and pull out each piece of data from the response. So instead of writing one-off prompts, you can build systems that extract 5 to 10 pieces of info from a single call. For example, if we're giving the model a bunch of web pages and we want to know what they're about, an interesting fact from one of the pages, and any links contained in those pages, we would use JSON for that. We also use formats like Markdown and XML whenever they're needed. And to make everything more reliable, we use tools like Pydantic and BAML, which basically turn prompts into functions that always return what we expect. Speaking of expected outputs, LLMs are really good at copying patterns. So if you just feed them examples, they can get pretty damn close to matching the tone and the format, even without fine-tuning. Here's an example. If you want your AI model to help you write a tweet, you can use a prompt like this, with examples included to show your AI model what good actually means to you. The quality of your outputs will be way better. One thing we did at Friday Labs was create a database of both good prompts and examples of good outputs. We reference this at any time, and we don't need to come up with the examples from scratch for every prompt we write. For whatever reason, nobody really knows why, but AI responds a lot better when things are clearly labeled. One of the best ways to do that is with tags. So if you've seen HTML before, it's the same idea. Tags tell the model everything inside here belongs to this category. It creates structure, and structure makes the model smarter. You can tag inputs like context, task, or examples, and even ask the model to respond using these same tags too. That's especially useful when you're building custom chat interfaces or if you're parsing responses programmatically. It's simple, but it works really, really well. So when you're writing these prompts inside of a broader system, especially automated workflows, you need to think about variables. A prompt shouldn't be hard-coded with one product, one date, or one name. Instead, you'll set placeholders like product name, target audience, or today's date. Then, you'll dynamically insert those values when the system runs. This is how you go from a one-off chat to a repeatable, scalable system. So if you're building in Make, Zapier, or N8N, using variables like this turns your prompt into a template, which means the same prompt can generate thousands of different personalized outputs automatically. But prompts almost never work perfectly on the first try, and so you'll usually want to test different prompts. That's why Google introduced 4 iteration moves, which are basically just ways to rewrite prompts. You can add clarity, like breaking your long prompts into shorter sentences. You can switch the frame, like saying write a story instead of write ad copy. You can use constraints, like saying maximum 3 bullet points or 10 words each. And then you can revisit the framework as a whole. You can recheck the task, the context, the examples, etc. Something we use a lot at Friday Labs is a concept called meta prompting. It sounds complex, but at the core, you're really just asking ChatGPT to write you a better prompt. We use PromptLayer to version control our prompts. That way we can look back, see what we've tried, and evaluate the quality of each version's outputs. Then we know we're constantly improving. And another thing that tends to provide really good results is chaining together multiple prompts. You don't have to ask for everything at once. For example, you can ask one AI model to summarize a blog post in 3 bullets. Then you can ask the next AI model to turn the best bullet into a tweet. Then you can ask the next model to give 3 different versions of that tweet. That's called a prompt chain, where one output becomes the next input. And it's really helpful for breaking complex tasks into a series of simpler ones. Speaking of prompt chains, let's talk about one of the most powerful prompting techniques that exists: chain of thought. It's been a big focus in the AI world lately, and for good reason. If you look at artificial analysis, all 11 of the top performing AI models right now are trained to use chain of thought reasoning. Why? Well, instead of jumping straight to an answer, the model is asked to think through the problem step by step. And you don't need a special model to do it. You can actually just add a line like this. It slows the model down, it makes the output smarter, more accurate, and more structured. And if you're building this into a system, you can use something like reasoning tags so that you can hide that part from the final output. There's also a slightly different method called tree of thought. Here, you ask the model to think through multiple different strategies before picking the best one. This forces the AI to compare different options, which is great for content plans, product ideas, decision making, or even multi-step agent workflows. Speaking of agents, writing prompts for them is quite a bit different. But luckily, tons of system prompts from real AI agents have been made public. You can reverse engineer how tools like Cursor, ChatGPT, and Replit all set up their agents to perform well. I'll leave the link to those system prompts in the description. Cursor's coding agent, for example, uses a massive system prompt that is hundreds of lines long. When you break it down, it's doing a few very specific things. It's defining the agent's role in extreme detail. It's listing the tools or the APIs it can use. It's outlining how to respond depending on the task. It's adding guardrails for what not to say or do, and it's giving examples of good outputs. So remember, when prompting agents, here's what's really important. You wouldn't just say you are a helpful assistant, you'd be specific. Your agent needs complete role clarity. It also needs to know what tools it has access to. So if it has access to tools, APIs, databases, calculators, you have to tell it when and how to use those. With AI agents, you probably also want to give it memory. So using past assistant or user messages to simulate memory or recurring context. So you can use the conversation history in this part, or if you're using a RAG system, here's where you'd implement it as well. And then failure handling. You want to tell the agent what to do if they don't have enough info. AI agents are more than just fancy prompts. They're literally small systems, and the system prompt is the blueprint. So I would design it like you're building a real teammate. Most of the models today can handle images, audio, video, and code, so don't limit yourself to just prompting with words. Let's say you're building systems for a real estate agent. They want help writing property descriptions. Which of these prompts do you think is going to give you a better output? Well, the one on the right has way more context, and it actually shows the AI model what it's describing. So the output's going to be 10 times better. And I have to note this, but AI isn't perfect. Sometimes it lies, sometimes it's biased, and you can't fully eliminate it, but you can reduce the risk. You can add guardrails to your prompts like only answer using the info provided, or if you're unsure, respond with 0, and then just stop that from occurring or reprompt the model. But you can also set up custom prompt validators. This uses another AI model to evaluate the output of the first one. You can do this however you want, but for example, let's say we're building a customer-facing AI agent, and we want to make sure that it never reveals company data. We can use a separate prompt validator model to review each of the responses and make sure that it doesn't have any company data in it. In our agency, we use custom validators for anything client-facing and most of our internal models as well. The only thing you have to remember is that this adds both latency and cost. The second model takes time to run, and it costs money too. And I'll end on one of the strangest prompting hacks I've ever found, and you need to be careful with it. But you can threaten the AI model. Seriously, even Sergey Brin, the co-founder of Google, said it himself. So years ago, I found a line buried in one of these open source system prompts that said this. So I tried adding it to my own prompts, and weirdly, the quality of the responses got a lot better. It's dumb and hilarious, but it does work. So if you remember the 5-part framework, task, context, examples, evaluate, and iterate, and stack that with everything else we talked about today, you'll be miles ahead of everyone else that's trying to catch up. And that's what I'm here to help you do. So I'll see you in the next one.